Thank you. That was a fantastic introduction. And also, I loved your talk, like space and Swift. I should have worn my ESA hoodie. I am the co-founder of Telemetry Deck, but I really wanted to build a sex app. I had this slightly tipsy discussion with a friend about various topics, and that discussion turned into me making an app that tracks your sexual activity and your mood and other factors. And then I also added tracking for your menstrual cycle if you menstruate, because why not? Apple Health had just added an API for it, so there was no reason to not add it. And then that's how I met my best friend, Lisa. She wrote me on Twitter that my cycle tracking sucked and I didn't have any clue about the menstrual cycle. And I was like, yes, you're absolutely right. Can I invite you to drinks and you explain to me how to be better? So that's how we started both working on this app together. We improved the UI. We tried to make it as non-sleazy as possible. And we wanted to make sure that the app was usable to as many people as possible of all genders and orientations. And at some point, we wanted to add some form of analytics. Did people turn on the daily reminder notifications? Are people using the app longer than a few days? What kind of screen sizes and languages are people using? And I checked out a few analytics products, and all that I kind of researched were either very complicated, or they were kind of hard to set up, or they didn't really support Swift UI yet, or they required a load of user consent because they wanted to basically slurp all kinds of data about my users, including personal data, because they were kind of reselling that or using that. And for an app that collects that kind of very intimate data, that felt incredibly wrong to me. So I thought, it's just sending a few metrics to a server. I mean, I have a lot of experience writing server-based applications. How hard can it be? Pretty hard. I had previously worked on various privacy-preserving products, so I knew people with a lot of experience on how to anonymize data, and also how to recognize the same user each day, making a connection in one direction without allowing the data to be connected back to the original user, basically. And so that's how I started. I have, as I said, some experience with Django, Flask, and Rails, but I thought, hey, this is the ideal. This is just a stupid side project. There's nothing riding on this, so I can use this to finally try out Swift on the server, because that's something I've been hearing a lot about. So I built a little Vapor app that would just store the analytics events in a database. And then, of course, almost immediately, my friends also wanted to use it. That was back when Twitter was for decent people, so I posted there and I got all kinds of requests for, hey, can I use this too? Can I use this too? So I used Swift UI to build a little user interface, and I added the absolute minimum of user management thanks to Vapor. And it could just display these basic charts. That was before Swift charts, so these charts are all handcrafted. So yeah, I let my friends use it, and then the COVID lockdowns hit, so I had just lots of time to work on this. Lisa and I, slowly added support for more platforms, and we started getting a few larger apps to use telemetry Deck. Back then, I think Apollo for Reddit was one of our customers, which was really nice. But more data, of course, meant more problems. Postgres really isn't made for time-based analytics data. Asterisk. Let's talk deeper if you disagree. But there are specialized time series databases. So we moved all the storage of analytics events to a time series database called Apache Druid. And I also added a specialized ingestion API to accept data, put it into Druid. do a few anonymization steps, that kind of thing. And these days, this is how data streams into telemetry deck. It's collected and anonymized by our SDKs on device. It goes through NOM, our ingestion server, where it gets another anonymization step, and it goes into a message queue and then finally lands in Druid, where it's being picked up by the Swift-based API to display. On top of that, we have a web application these days for our customers, which just displays the charts and does user login and management and other this is analytics platform things. This is what it looks like. Interested. And because I spent a lot of time in Vapor for the last 4.5 years, I have some, I call them lessons, but they're more like anecdotes. Let me just tell you a few of them. These are 9 separate anecdotes. They don't have really a lot in common with each other, but they might give you an idea, how did I do this, or how not to do something. Sometimes there's a lesson in there, but my conclusions, of course, should not necessarily be your conclusions, but it might be an interesting view at us. So yeah, take everything I say with a grain of salt. Let's start with number 1. One thing that with my background, I always, I wrote a lot of APIs in my life. I wrote RESTful APIs, functional APIs, spaghetti code APIs. You could call them via HTTP or WebSockets or whatever. They would return JSON or XML. But one piece of advice that was always the same and that I always adhere to was version your APIs. This is, of course, very basic. Most of you know this, but I wanted to emphasize it a little bit because it's just really, really helpful. The reason is this is going to give you so much flexibility going forward. You can correct mistakes. You can change the behavior of your clients without breaking compatibility to existing clients out. And you might think something like, oh, but I'm the only consumer of this API. I'll just update the client and the server at the same time. But that almost always breaks at some point, because if you have customers, they might not, with apps on their phones, for example, they might not automatically immediately update their apps. If you have a web application, that might be cached in some browsers. You have just some of your own code that you just forget to update, which happened to someone I know. So yeah, you just at some point things are going to break if you don't version. So how do you version your app or your APIs? My recommendation is put a version number at the earliest possible position in your path. Some people would argue they would try to version individual sub-APIs, in the middle here. But my recommendation is do not do this, because at first it seems easier because, oh yeah, I'm just updating the organization's API, so I don't have to cycle my own version number and everything. But what this gives you, or what you don't get with that sort of versioning, is the ability to change your whole tree structure of your API. So this is why my recommendation is put just a v1 at the very beginning of your path, and then just at some point later, you're going to think, oh, wait, I'm going to change the structure. I can do that now. So because having that flexibility is just so important. You might make mistakes, or you might realize that things should be structured differently, and just give yourself this freedom to change later. Version your APIs. Next up. I have a story about data transfer objects. DTOs, we probably all know this, are the little structs that you return in your API controllers, or they are the structs that you decode when receiving data from your end. In my version 1 APIs, I really wanted to have DTOs in a separate Git repo. So this was because I could share them then with the native app. And it's a really tempting idea because you can be absolutely sure that the same data is being decoded as it's being encoded. And this worked really great until I wanted to go to API version 2, and then suddenly some of the input types are different. And where do I store them? So I had unintentionally introduced a weird coupling between API versions because that is something that I usually try to avoid. So now I had to copy all my DTOs and kind of namespace them because they are very different but similar structs, and they were this was a source of a lot of friction. It doesn't look like it maybe, but every time I was changing the behavior, I had to go to the submodule. Annoying, don't do that. Especially because then my buddy Peter Steinberger convinced me that we needed a web app. So he said, most people aren't going to install your desktop app. Some people don't have Macs. It's harder to link to you. It's harder to sign up. Just make a web app. So we kind of made a web app, but at the same time, it's too hard for one person or two persons to maintain two different front-end code bases at the same time. So the native app fell to the wayside. And with that fell to the wayside, the entire reason for this whole Git submodule, sub-package kind of thing, construction. So I had all of the downsides, none of the advantages. So with version 3 API, what I did is I moved all the data transfer objects into their respective controllers. They are now inline structs. They are directly coupled to the controllers. This is what this looks like. This is, of course, pretty basic and probably what most people already do, but I went on a huge round trip to tell you the grass on the other side is not greener. This is good. Just do this. This makes a lot of sense. It's easy to work on the code, and it's also easy to change the DTO for just one controller because it's right there and it's not coupled to anything. So my recommendations, keep your DTOs inside or close to your controller. I have worked on so many projects that kept old APIs around as long as possible. But who has the time to maintain all of those? Especially for our internal APIs, I try to deprecate them as soon as possible. I want to throw away old code that I'm no longer maintaining because it's a security risk and it's not helpful and it just feels cleaner to me, to be honest. So once an endpoint in the v3 API is reasonably stable, I try to update all my client code to only use that endpoint instead of the v2 endpoint. And then, once my metrics tell me that the v2 endpoint is no longer being used, I can just delete it. And when only a few v2 endpoints are left, and these are staying the same, I can just move those files underneath the v3 route. And, well, sometimes you actually have code that should be executed by both the v2 and v3 route, but maybe because you want to maybe keep both of those endpoints available for a bit longer, and then you can just point both the v2 route and the v3 route at the same code. No one is stopping. You might want to add a comment to remember that if you ever change the behavior to copy on write, basically. But this is a pattern that you can. It is also very helpful to use the @available deprecated modifier. I use that a lot for database fields that I don't want to use anymore. So I just mark them as deprecated, and everywhere in my code I can see, oh yeah, this is probably something that I shouldn't touch or I should move away from. Right, I mentioned metrics for my APIs. How do I collect those? Well, it turns out that a few years ago, I didn't have anything available. I looked at stuff like New Relic, which I've used before for Django, for example. There wasn't, a few years ago, anything compatible with Swift on the server. But wait, I do have a quite powerful analytics platform available, if I do say so myself. So there's a middleware that just each time a request comes in, it sends a telemetric event to us, basically, to ourselves. And that includes not the URL, because that might contain identifiers, but it does contain the path, which is basically the URL without identifiers. So it's the same for each call to an API endpoint, regardless of what object is requested or manipulated. And that is really helpful because it shows me, A, how long are these requests taking? Because I also store like the duration of the requests. So which ones are slow requests that I should look at? Where are errors being thrown? And also, which APIs are actually getting used? And that kind of folds back into the point about like deprecating old unused APIs. And so basically this is how we use telemetry deck to monitor telemetry deck itself. And that works surprisingly well. Just one downside, of course, is that this is not very detailed. Like you only get the total time that a request took, but not like where did it spend that time? Like was it waiting for the database? Was it like doing some weird calculations? Was it some other thing like caching or whatever? So you don't exactly know which part of the system is your bottleneck. And for that, in the future, I really would like to adopt Vapor's tracing middleware. Vapor tracing is, of course, based on Swift distributed tracing, and it got merged on Christmas last year. So I just want to thank the developers for this fantastic Christmas gift. And I'm really excited to adopt this soon. And I'm going to have to think about like how can I get this into telemetry, or do I need like something to receive that? For machine level metrics, we use Grafana and Loki. This is pretty low level, but it's really helpful. And it's very easy to install because we use Ansible to deploy our machines. So this is just a role that we can throw on all the machines, and they will immediately send CPU usage and kind of stuff to the Grafana server. And this, of course, helps us identify machines that are maybe doing something wrong or that are struggling, and to react very quickly. We also use Loki to gather logs from the API containers. So that helps us see very clearly and early if like a container is struggling, or if it's like throwing many errors or warnings or even crashes. Because we have like a bunch of containers. If one crashes, you might not know if you don't look. For uptime monitoring, we use BetaStack. This is where you define a URL, and BetaStack will just like hit that URL every 30 seconds or so, and if it's no longer responding, or if it's responding with an error code, you get a call, and you get one of those notifications that you can't silence, which you usually would get at 3 in the morning, of course. So I kind of hate it, but it's also very helpful, of course, because you immediately know that something is wrong, and it's not like your customers will then like write to you the next morning, like, why is everything down, which is something that would happen. So it's a good last line of defense to have this. I'm really happy. Like, this is not an ad. They're not paying me anything. So what I do is I have like a number of health APIs. So I have like /health/database /health/druid, for example, which one of them would test if is the database available. One of them would test like is the analytics data queryable. One would test like is the login working? Can we send events to a telemetry deck? So they would like throw an error, and then I would get the call. So this helps me keep an eye on things and just like make sure that everything is still. So caching is cool and fun and important, even if you use Valkey. Because it protects your database and makes things faster. So every time an API request triggers something that is expensive, or it's probably a good idea to cache it. And that makes like repeated calls to a slow API faster. So it's a good defense mechanism against being slash-dotted or fireballed or overrun by a stampede of happy customers. So at the beginning, I had one instance of my API project, so I could just use the RAM cache that Vapor brings us, and all was well. But then with multiple container instances, I wanted to keep the cache consistent between instances, of course, so I switched to Redis. And then later, Valkey, but with the Redis Stack SDK. Didn't know. But then suddenly, AWS Redis/Valkey is costing me around $1,500 per month because they charge by the amount of data stored. Because if your RAM cache is full, it will just drop the oldest keys. Like nothing bad is going to happen. But Elasticache Valkey doesn't have a maximum size if you don't actually define one. It just grows and keeps your stuff. So the very expensive lesson that I learned here is my expectation was that cached values would always automatically disappear after some time. Turns out that was wrong. My solution was to set a maximum size on my caches, and also I now always set an expiration date on each time I cache something. Anything between 2 seconds and 2 days are usually good caching expiration dates, TTLs that I use. This I feel a bit ashamed that I needed to learn this, but maybe it helps you not repeat the same. Here's my general guidelines on when I use caching. I cache things that are requested very often, like multiple times a second. Like when Dave linked to our notebooks the other day, I was kind of happy that they were cached, especially since the Financial Times linked to us at the very same. I also cache things usually that requests outside services like Stripe to not run afoul of their API limits. And I also cache things that take multiple database requests or are very expensive to run on the database because I want to. So yeah, caching, fun and cool and important and very expensive if you get it wrong. I want to talk to you about how I used queues and jobs. So at the beginning, I had a few tasks that I needed to run once a day. For example, deleting expired user tokens. And so I just ran those as scheduled repeated tasks. But then I had a few more, so I wrapped those in this code into a protocol that I made for myself, and it felt way cleaner. And then I added a bit more code because a bit later I had a problem that too many analytics queries were reaching the Apache Druid server at the same time. So I needed some way to queue up those queries. And that should have been the time where I switched to Vapor queues, which is just included basically in Vapor. But I already had lots of fantastic code of my own, and somehow I didn't feel like learning something new, so I wrote even more, built my own queuing system using lots of custom PostgreSQL commands to avoid race conditions and this worked for a long time, but it added even more complexity that was hard to manage and maintain. And especially when I added even more queued jobs and repeated tasks, at some point I was spending just too much time on this system, and finally I broke down and re-implemented the whole system in Vapor queues, and what can I say, it's just way better now. So this is how little code I need again to schedule repeated tasks now. What I also added to the default implementation of Vapor queues is I modified the database a little bit so I can keep finished tasks around. So I'm storing them in the database instead of on Redis or whatever. But that gives me also a tiny admin interface that I built for myself, and that is really helpful to see how many jobs are actually run, and also if one has failed, I can see the logs and the output. And of course I have metrics for this as well. Fun fact, I have a countdown on my screen here that tells me how much time I still have. I configured it wrong. I have 29 hours and 35 minutes left, so strap in. So external services, and also this is also about the whole ecosystem of open source and working together and everything. So early on, I basically chose any external service provider by just what SDKs were available. Case in point, the only email sending provider that had an unofficial Vapor SDK was Mailgun, so I used Mailgun. And I also used Stripe, and luckily there was a Stripe kit, so that's kind of fantastic. Also, quick shout out to other tools, of course, in the Vapor ecosystem, especially Imperial, which is awesome, and like so many, too many to come. There was nothing for Apache Druid, so I wrote my own, like first just like some gnarly HTTP calls directly in the code, but like this is, I'm extracting this out into its own package, and I might even open source it at some day. But because like this is way cleaner and it doesn't have dependencies on Neo and whatever. But then StripeKit seems to be abandoned these days, which is a bummer because I really needed like a few more APIs because we want to have more billing options. And I did add a PR for these APIs, but they never got merged. So it seems the maintainer for StripeKit is not available these days. So what I did is I started maintaining my own fork for telemetry.StripeKit. Of course, I will continue sending PRs to the original StripeKit project instead, in case the maintainer comes back. Apologies. Or if someone else can be found on the. Get a drink. Then I also didn't like Mailgun anymore. I was kind of becoming unhappy. So I wanted to try Brevo. So what should I do? They didn't have a SDK for Swift. What they did have, however, was an open API specification of their API. And this is fantastic because Apple have a project called the Swift Open API Generator. You put in an open API specification and out comes a complete Swift project with functions for each of the endpoints. Also shout out to Swift package index, of course. This is not perfect. It's very complicated because like it's all auto-generated and kind of spaghetti, but it's a fantastic start. It's very low level, but you can wrap around a usable SDK around it. So I can build an SDK around it with my convenience functions that I want. And that is being open source as well. I think it is open source already. So you're welcome, Brevo. But yeah, like seeing that actually convinced me to be even more, like to contribute even more to the ecosystem because I'm seeing, oh yeah, this is so cool to give back. And especially like seeing everyone here also is like super helpful and fantastic. Like I was complaining online about like, oh, I wish there was something like DjangoCon but for Swift on the server. And then Michaela wrote to me like, wait, but there's ServerSide.swift, right? And I'm like, oh my God, I need to go there. And I'm learning so much about like the bigger ecosystem that I can like replace half of my code with like without like reinventing the wheel 17 times next time. Almost last, I have some thoughts about migrations. I love Vapor/Fluent's migration system because it works very similar to the one that Django uses, and that is just very good. But there's one thing that annoys me or that I'm missing. There are too many migrations in my code because the project has lived for a while. And I notice this whenever the tests are run. Each test like gets a fresh database, right? So every time like one single test case is running, it gets like 100 migrations migrating and then like regressing again. So one thing that I miss is the ability to squash migrations. Like in Django, you could combine all the old migrations into just one big migrations that would run at once. And so for these tests to run, that I would have like one migration per database model, and that would be really cool. So Vapor doesn't have the ability to automatically squash these migrations, but I asked a bit around, and Gwyn says, in theory, if you build a custom migration yourself and use that to replace all your migrations, it should work. I haven't dared try it out yet, though. Maybe that's my talk for next year. And this is the last thing that I want to talk about, basically. I have a super tiny bonus tip for if you are building your Vapor API project using Docker, because Like this is something that I was hoping to improve for some time, which is the build times. Like my project on my build server takes about 10 minutes to build, and I deploy pretty often, especially to staging. And this is, of course, annoying if you want to wait like 10 to 15 minutes until your project is built. So Docker has this like staged or layered file system where each of the lines in the Docker file actually builds a new layer. So if you can force it to use a cache for the upper layers, then you can also try and use the existing build cache for a previously built container. So if your build server pulls an old image from your Docker registry, and then you convert your Docker file to first build just your dependencies, and then only add your code, your build times will usually increase way. So my builds now take a minute. This is pretty cool. All right. Here are my lessons. Version your APIs. Keep your DTOs close to your controllers. Deprecate aggressively. Observe, instrument, cache with expiration dates. Use VaporQ and use the ecosystem in general. Also give back to the ecosystem. Right. So the Sex app is off the App Store now. It never was in the App Store. It was like a test flight, I think. In the end, about 200 people were using it. Meanwhile, Telemetry Deck is serving around 14 million users per month. It is like paying for the sandwiches about 5-ish people. And I'm pretty happy with how things turn out. Thank you.